So here we go with our different ways to show comments in the computer. One, if we start a line with a hashtag, then the computer does not see this. And this part here was actually created by the computer. It shows the computer what language it's using for the characters. And you don't need to know about this too much. It's just going to make it automatically in my computer. And it does nothing at all to the computer program. This is just a message for the computer program. So here is another message, and it's several lines long. It doesn't start with a hashtag. It starts with 3 quotation marks, double quotes, and it ends with 3 double quotes. This one here is called a multi-line comment. And here it's just the name of the program and the time that the program was created, using Python to study mathematics. And of course our overall topic is functions, because that's our course. Alright, so here's another multi-line comment with single quotes this time. So, and here's a little note about what we're doing. Why are we using a computer program? This is mathematics class, isn't it? Well, the computer program is a powerful tool for learning mathematics, and it can make our calculations more efficient, allowing students to spend more time focusing on the ideas. So this video will introduce a few ideas that may be used to improve mathematical understanding through the use of the Python programming language. So why did I choose the Python language? Well, A, it's free. B, it's very quick to learn compared to other computer languages, and you will be able to use this in many, many parts of your life. So as a math or science student, computer programming language is invaluable. It's impossible to learn all of the things there are to learn in the time you need to learn them without such a tool as this these days, because there is so much that a computer programming language can do to accelerate your learning process. So some of the topics that are covered in this video, they're in some other videos, and you may want to look them up online, learning about Python comments, mathematical expressions, variables, decision structures, loops, lists, functions, and libraries. So these are all things that you will need. And I have produced a number of other videos that do just this, and you may access these. We'll gradually offload them so you can access them everywhere, including Canada and China. So here is a little example. Because I'm using later in the program here, I have some sample code down here. I'm going to need to import the mathematics library. And I'm putting a comment here. So I just imported the mathematics library, and that allows me to use certain mathematical functions that we'll see later in the video here. So here's the first actual line of code that is not a comment, and the computer will finally do something with this, and it says basically here to import everything from the math library. And that's like telling Python to go to a bookshelf, find the math book, and read its own math book, and remember everything. The star means everything. So now it will know how to do certain math, not just addition and subtraction like you see in these expressions, but some of the other things that are later in the video. Okay, so using math in Python, well, we can do some basic calculations. So I'll call this basic calculations. And this is particularly order of operations. So I have some brackets, I have some addition and subtraction and division and multiplication, and they're done in a certain order. Brackets first, then exponents, we don't have any exponents here, multiplication, division, addition, and then subtraction. Well, what if I were to include some exponents? Well, I could take this line and do this, but it's going to be 4 to the exponent 2. So there's a nice little note. The double stars, this is exponents. So 4 to the exponent 2 is equal to 4 times 4 is equal to 16. So that's what the 2 stars mean. 4 to the exponent 2 is 4 star star 2. Okay, so this program here, it's all commented out with a multi-line comment except these 4 lines of code. And so our Python program is just going to print 3 numbers, 1, 2, and 3. So you can think about it for a moment. You can pause the video and try to predict what is the output going to be from each of these expressions. Well, we're going to see here in a moment. This is the output area. I'll make it bigger. And when I press play, which is right here, it will execute this code. It'll read the math library and then print out 3 calculation results. There we are. The first answer is 16. The second answer is 0. And the third answer is 12. Okay, and so you may reflect on, well, how did Python get 16, 0, and 12 as the answers to those 3 calculations? So there's the first use of Python. At very least, it can act as a very powerful calculator and enter long expressions. And it will help you to do very good calculations, much more powerful than a handheld computer or phone, or sorry, a handheld calculator or phone. Okay, so basic calculations are done here. Now let's move on to some topics that we'll encounter in our course. The various chapters of our textbook that you saw yesterday cover these various topics here. So first of all, the notion of a function. And I've presented here 2 different functions. This one is 3x squared plus 4x plus 3. So there it is there, 3x squared plus 4x plus 3. And this one is 5 times x to the exponent 4 minus 10x to the exponent 3 plus 3x to the exponent 2 plus 2x to the exponent 1 minus 5x to the exponent 0. In fact, I could do this to the exponent 1 and times x to the exponent 0, just to keep the pattern good. I don't have to put this in. X to the exponent 0 is just 1, and x to the exponent 1 is just x. Alright, so now I can use these 2 functions like this. I'll print out f1 for the value of x, that is 5. And I'll get an answer. And then I can print f2 for negative 10. And it would give me an answer. So I'm just going to comment out the previous part of the program. So we just focus on this code right here. It's going to print 2 numbers now. First, if x is 5, we get 25 times 3, that's 75, plus 4 times 5 is 20, is 95, plus 3, it should give us 98. And similarly, this one should give us a much different number with powers of 10. So you can pause the video if you like, try to figure out what this will be, and it will just give us 2 numbers. So let's play or run the program. There we go. The first one was 98 indeed, and the second one is 60,275. So again, imagine trying to do that on your calculator and making a mistake. Well, this one, if you make a mistake, you say it was not supposed to be negative 10, maybe it's supposed to be negative 9. That's okay. Now we do a new calculation, and there it is. What if we want to do it for a different value of x? What about f2 at 5? There, now we get a different value when f is 5. So there we are. Polynomial functions can be calculated very handily with Python. And so this is one type of function that we will deal with particularly a lot in our course, especially functions where the highest power of x is 2. So this one here, this one is a quadratic function. And down here, this one is a quartic function. And why is that? because the highest power of x is 4. And when the highest power of x is 4, we have a quartic function. When the highest power of x is 2, then we have a quadratic function. Alright, so there's calculating using polynomial functions. Now, what about if you would like to do this code? Let's say I have a snippet of code here. You can copy it and paste it into this online program here. So I have it installed on my computer in a program called Spider. But over here, then we will see there's another program, and I might have to open this up here on a different window. So I'm just going to open a different window here so you can see that in the video, and we'll just say window capture for a new window, and we'll do the whole desktop. Okay, here we are, and then we'll take down this one and this one, and hopefully now we should be, oh, that's just the desktop. We need to open up a third window here for let's open up this, or how about this one, and we'll take off the desktop. There we go. Okay, so now we'll be able to see this program. So I copied from one window to another. So now I have the code in here, and you may run it just like this. We press run, and there we go. There's the answer. And if you remember, I had a -10 there. And run, and it does a calculation. So when I set x equals -10 for this function, here's the answer that I get. So you can see how you can calculate the value of a polynomial function using this approach. So we'll just switch back to the other window here. So this code calculates and there I just wrote a little note there. This code calculates the values of two functions for given values of x. f1 is the first function and f2 is the second function. So you'll note in math class we usually use f at x. But here I have several functions, so I just named it f1 at x and f2 at x. You can name it anything you like in a computer program. But since I named it f1 and f2, then it's kind of similar to math class. Alright, so that's polynomial functions. That's a large part of our course, especially quadratic functions like you see here. So now I'm opening up a new topic here, and I'll calculate two new function values. Right here we have rational functions, and f3 and f4 are two rational functions. Well, what are they? Rational functions are the quotients of polynomials. That's a division. See, the numerator divided by the denominator. So there's some good vocabulary. So we have the numerator, which is on the top, and it's divided by the denominator on the bottom. There we go. And so here we have function 3, 1 over x minus 4, and function 4, 3x squared minus 4x plus 1 over 2x squared minus 5x minus 4. And just like above there, we can just print f3 at 10, and maybe print f4 at -1. And we'll see how that works. Okay. And I got two values, 1.166 repeated, and the other one is 2.66 repeated. So imagine again trying to calculate that in your calculator, very slow, but here once you enter it, then I can try all kinds of values. Every time I change a number, then I get a different value or a different result. I can even do it for very big values, like here's 100. Whoa, doesn't matter. For 100, it just gives me a very low number. How about, that's 1,000. And what about for very long and complicated decimal? No problem. It just loves to do the calculations. So Python is very powerful, and it will very quickly get your work done compared to your calculator. So this is a very powerful calculator for you to use. So there we have rational functions, a second topic. So we will comment these off. And now we'll go on to a new unit. We're just previewing the whole course. And here we have some trigonometric functions. And yesterday in our course preview activity, we talked about all of these. Here's the sine, the cosine, and the tangent. And each of them has a reciprocal function. So we have the three basic ones, sine, cosine, and tangent. And then the three reciprocals, cosecant is 1 over sine, secant is 1 over cosine, and cotangent is 1 over tangent. And so I just put a value of x, 4.5, and it's going to print out for me 6 results. There we go. And I have 6 results for the trigonometric values for x. So those are 6 functions we're going to learn about in our course, and they're based on triangles. So we will talk a lot more about these, but suffice it to say that you may use Python to do some of the calculations here. Okay, so we won't spend too much time on these. We'll go on to sequences and series, yet another part of your course. Okay, so here is the definition of a arithmetic sequence. So A is the initial value, and D is the difference between each new values and the old value. So 5, and we add 2, it's 7, and we add 2, it's 9, and we add 2, it's 11, and so on. So that's what this arithmetic sequence looks like. And so now I have a little program here that uses a loop, and this is called this loop, starting with the 4, it repeats commands for values of n in the range 0 all the way up to, but not including, 10. And so it's going to print n plus how many differences we have, and you should see that it will give us some numbers starting at 5, 7, 9, and so on. Oops, I just made a slight mistake here in the code. There we are, and we'll try one more time. There we are, 5, 7, 9, 13, so on all the way to 23. So this one printed out for me an arithmetic sequence. So using very basic computer code, this is called a loop, and you can see other videos on loops and see how they work, but you see here it repeats the command. I only made one print statement, but look how many times it printed, because it's in a loop, and it repeats, but every time it repeats, the value of n is different. First, n is 0, so we have 5 plus 0 times d, which is 5. And then n is 1, we have 5 plus 1 times d, we get 7, and so on. So this one's called an arithmetic sequence. Alright, so that's the first of a number of arithmetic and geometric sequences and series. So the next one here is a geometric sequence. It's the same in that we have a set of numbers, one after the other, except now we call the difference between them is not a difference, it's actually a ratio. we multiply every time by r. So every time we multiply by 2, so we're going to be 5, and then 5 times 2, and then 5 times 2 times 2, and then 5 times 2 times 2 times 2. And then we should see a very interesting progression of numbers here. So let's see what this one looks like. Starting with 5 and multiplying by 2 every time, what do we get? Oh, it actually started at 2.5. A times r to the exponent. Because my n started at 0. I should start at there, this way. There we are, 5, 10, 20, 40. Every time it's doubling, it's getting twice as big. So this is called a geometric sequence. And the reason it had a little issue, in computers, we start counting at 1. So I should, in computers we start counting at 0, but in math class, we start counting at 1. So I should have made it to be like in math class. I'll start counting at 1 here, and then make this n a negative 1. So the first value of n is a 0, and we get the same result, actually. Except we only go up to 1280 this time and not 2560. You can think about that and ponder upon the difference between computers class and math class. In math class, we start counting in 1. In computers class, we start counting at 0. Otherwise, everything is pretty much the same. All right, 2 more little ideas to discuss in this video. And the first one here is an arithmetic series. What is the sum of a set of numbers? So for example, up here, we did a sum of numbers 5, 7, 9, all the way to 23. Well, what would be the sum of these numbers? So n started at 0 and went up to 9. There are actually 10 values of n. And we start at 5, and we have a difference of 2. So I'm going to try this, print arithmetic series. This is a special kind of function like we have in math class, but now we have 3 values, not just x. We have a, d, and n that we can give it. And so I'm going to say the a was 5, and the d was 2, and the n was 10. And if I print that out, I should get the sum of all those numbers. And I just made a slight error on line 102. There, try that again. There, the sum of all the numbers should be 140. Well, you can try and see if I got it right or not. Maybe I have to adjust my n. I'm just sort of speaking and working at the same time. So this adds all of the numbers that you see up here, and it should come to 140. If not, I may be off by 1 number or so. Okay, and that's adding. A series is just the sum of a sequence. So there's a nice statement for you to remember. All right, one more example to do, and we'll take some time to do some review. So here's a geometric series now. What's the sum of our geometric series? We'll try the same thing. Print geometric for a, r, and n. Well, a is going to be, well, what were we using before? 5. R was 2, and let's try it for 10 terms. And see if we added that for 10 terms, what would we get? Well, the sum of all the terms should be 5,115. So there we have the sum of the arithmetic sequence, which is called an arithmetic series. And we have the sum of a geometric sequence, which is called a geometric series. And in so doing, we now complete a very quick tour of our whole course, but we connect it all to the Python programming language. So we can use Python as a very powerful tool. So just a little note. In this course, you will not be asked to program a computer. You will be asked to use computer programs. So I will prepare the programs for you and you use them, but you may be interested in learning more. So some of you will naturally be interested in computer programming, especially those who want to go to university and study math or science. Computer programming is more or less an essential part of your work, and so you will be definitely interested in learning more. And of course, you can take these examples and work with them. You can use it to solve or work on your homework. You can use it to learn computer programming on the side, and you can use it as a way to remember all the things that we're talking about in class. So hopefully this video will serve as a kind of a review or preview of the course, and also give you an idea of how you can use computer programming as a powerful calculator to help you do your computer programming work. So hope you had an enjoyable time. Now we'll have some time for some exercises.